Hello and welcome. In this video, we'll give an introduction to our RPA platform, UiPath. Our software platform consists of three parts: UiPath Studio, UiPath Robots, and UiPath Orchestrator. UiPath Studio is the designer tool used to create diagrams of business processes. UiPath Studio is based on the Microsoft Workflow Foundation and, from a visual point of view, is very similar to Microsoft Visio or other flowcharting software solutions. The UiPath robot runs the processes designed in UiPath Studio, the same way a human user would. It works either in fully autonomous mode or as an assistant. In assistant mode, a human triggers specific workflows, depending on their current needs. The fully autonomous robots can run unattended in virtual or remote environments and can automate any number of processes without human supervision. UiPath Orchestrator is a web-based management platform that enables remote control, monitoring, release management, and centralized scheduling of robots and processes. It facilitates both human-robot collaboration and business exception handling by using centralized work queues. It also offers analytics, insights, and it lets you create configurable reports or dashboards. Let's take a closer look at UiPath Studio. With UiPath Studio, you can design different types of workflows, sequences, flowcharts, and transactional business processes. Let's start a new blank project, which we'll name Test Demo. The panel on the left, called the Activities panel, allows browsing between the available activities. Activities are actions that we'll use to automate applications, like clicking and typing, and other data processing actions. This panel contains around 300 activities that allow interactions with desktop applications, web browsers, OCR engines, and so on. UiPath is also compatible with Excel, PDF, and all database types. The specifically designed activities for these third-party applications can run in the background without interfering with a regular computer operation. For terminals, there is a special wizard that allows us to connect to different terminals, such as green screens, mainframes, and others. As we cannot touch on that in this video, a document with all the details about the terminals is available on our website. UiPath Studio is also compatible with Outlook, Exchange, or any other type of email client that has an SMTP, IMAP, or POP3 server, and this includes Gmail. There are activities that allow for email attachments to be downloaded, read, or for new emails to be composed and sent. Studio can automate processes on web platforms as well, with HTTP and SOAP requests that can be integrated into the automation process. One of the easiest ways to create a workflow is by using the record feature. UiPath features 4 recording types, specialized in different domains: basic, desktop, web, and Citrix recording. Let's open the desktop recorder and a simple demo application, AnyTeller, to help us with a recording example. Our software supports any type of desktop application, whether they're written in .NET, Java, C++, Delphi, Fox Pro, or any other language. Upon starting the recorder, you can see that it can identify elements from other applications: labels, edit boxes, cells from a table, buttons, and so on. The recorder follows the exact steps that the user performs inside an application. So let's type the values in the cache in and not on us check form fields, and then click the accept button. Closing the recording wizard will create a workflow which replicates all the steps performed earlier. The Attach Window activity selects the AnyTeller application window, while the Type Into activities complete the Cache In and Not On Us check form fields. The Accept button is clicked via a click activity. Running the workflow will follow all the above steps. As you can see, the workflow we just created does not fill in the On Us check field. To add this manually, we'll find a Type Into activity in the Activities panel and drag it onto the workflow. The Indicate On Screen button enables the selection of the field that needs to be completed. Let's indicate the On Us check field and specify a value, 300, for example. We can also create a variable in UiPath instead of specifying the exact value. A variable is a place where values can be stored within a workflow. Think of it like a box where we can only keep things of one type. Let's name the variable onUsCheck and set it to be of type string, a type that holds text values. Let's set its default value to 4000, surrounded by some white space and quotes. We type some spaces around the number value to showcase UiPath's auto-completion feature. To get rid of these spaces and input a correct number value in our field, we'll look for a .NET function. In this case, typing full stop after the variable name will trigger auto-completion for the available functions. For our purposes, a trim function will do. This removes the spaces from the beginning and end of the string and leaves us with a string containing only digits. Running the workflow will fill in the onUsCheck field with the value of the variable. Until now, we have used UiPath to input values into an application UI, but our software can also get values from applications. In order to get the transaction number from any teller, we can drag and drop a getText activity from the Activities panel into the workflow. Just like the type_into activity, getText enables us to indicate on screen where the text to be copied is located. Indicating the transaction value will return it as a string and then store it into a variable. Let's define the variable as return text. To check if the return value is correct, let's add a message box activity and set it to display transaction, semicolon, followed by the contents of return text. We can concatenate two strings together by using the plus sign. Running the workflow, we can see that all the text fields are completed and the message box displays the correct transaction value. Great. Now that was pretty easy to build from scratch, but having values hard-coded in the workflow like this is not that flexible. The real power comes in when we parameterize this workflow and add logic to our basic recording. To see how to do that, we'll extend our example. Instead of entering static values in the accounting app, we'll get them from a spreadsheet, like this one here, 6 values for each text field. And we don't want to enter them blindly. We'll check if they are valid, or in our case, if the value of the cash in is greater than 100, the simplest validation step. We'll start by creating a new flowchart. It's a bit different than the sequences you've seen before, but just as intuitive. We begin with an action to read the spreadsheet, which is in CSV format. Indicate the desired file, and create the output data table. We'll call it DT. Next, we need to create 2 variables to hold the 2 values from the spreadsheet, and a third variable for the counter. Then, using a getRowItem action, we'll read each row in our data table using the counter. For the column, we'll specify its name, cash in, and save the value in one of the variables we created earlier. Now that we have the cash in, we can validate the data. We'll bring in a decision block, and for the condition, we'll set cash in is greater than 100. It's a very simple condition for illustration purposes, but it can be as complicated as you need. Notice the 2 exit ports of the decision block. Now when the condition is false, we'll display a message box telling us it's too small and nothing else. For the other option, when the value is greater than 100, we want to enter the data into the accounting app. We'll copy the getRowItem action, the one that gets the value from the data table, and use it to get the other column too. We could change the name of the column here, but we can also use indexes. It's the same thing. Now that we have the values, let's enter them in the accounting app. In UiPath, we can reuse anything, and that's what we'll do now. We'll just copy the sequence we recorded earlier and paste it here. Then simply replace the static values with our variables. cache in, and not on us check, and you're done. So far so good. Now this workflow will process the first row of the spreadsheet. To get to the next item, we'll increment the counter with 1 and check if we reach the end of the data table with another decision block. If the counter is smaller than the number of rows. If it's true, it means there's more data, so we'll send it to repeat the process. If not, we'll just display a message box. Now that's all. Just wire everything together and hit run to see how it works. Starting with the first row, it tells us that 21 is too small. 435 is fine, so it will be entered in the expense app, and the transaction number is displayed. The next row is again too small, but for the other two, the cash-in value is greater than 100, so they are successfully added in the app. And the process end message is shown. Now in just a few minutes, we created a pretty complex automation that reads data from a spreadsheet, validates it, and inserts the correct figures in another app. At this point, you may be wondering, how does the robot know where to type and click, and how come it doesn't miss? For that, we need to take a look under the hood to understand how computer vision is used to identify various buttons, text fields, and generally any other elements. We'll use a special tool called UI Explorer. It makes locating UI elements a breeze. Selecting the Edit box in the AnyTeller app using UI Explorer, for example, will show that specific UI element's path within the application. It's UiPath, so to speak. This path is based on the unique names given by the software developer of the application to each UI element. Generally, these names don't change from one version of a software to the next, so even if a software you're using in an automation receives an update that modifies its UI layout, the UI element names and attributes will remain the same. This will enable UiPath to still have a valid workflow in 99% of the updates, as the robots use these names for targeting UI elements. All these principles also apply to web automation. To showcase this feature, we can look at Google Calendar inside of a browser. On this page, we can identify each element, just like we did in the desktop applications. Clicking on an element, such as the date of 24th, will display all of its attributes down to the HTML tree. By default, the software selected DP0day24120 as an ID attribute, which is a value that a human can't really understand. We can select another attribute which is easier to understand, such as the date, 24th. To be sure that the robots are selecting the right element, we can select more attributes from the HTML tree. Now on top of that, if we use regular expressions and the wildcard character asterisk, the robot can select any element that contains 24 and starts with January 2017. This way, UiPath pinpoints the UI element using its underlying attributes, allowing for maximum precision within an automation. Now there's more to be said about computer vision, including a huge part about image automation that is used for virtual machines and other environments where it's impossible to access UI elements directly, but we'll get to that in a minute. Before that, let's create a more complex automation without using any code at all. You'll see just how fast we can build a workflow using our built-in data scraping wizard. This web page contains structured financial data. We'll use the wizard to retrieve this data, write it in a CSV file, and send it via email. All that in a matter of minutes. Let's create a new sequence. We'll click on the data scraping wizard and go to our page. The robot identifies that we're trying to extract a data table and asks whether the data is extending on multiple pages. We'll click No, and so the sequence is generated. Let's write the data in a CSV file. And send it via email. We'll first fill in the details, and attach the test.csv file. The robot will run in the background. It'll extract the data, write the CSV file, and send it via email. Let's check. And here's the email. Let's take a look at the attachment and compare the data. For example, for value 37, the last price is 1.26 and the bid is 1.25. Same on the web page. So the data is consistent. Now, as you can see, the scrape was successful and it took us merely minutes to write this automation without actually using any code. After viewing the basics of UiPath, let's look at a more complex process. We have created a robot that extracts data from an emailed invoice. The robot opens Outlook, enters the NPO Invoices folder, selects the email and opens the invoice. Since PDF is a text format, our software can easily recognize the data it contains, such as the company name, invoice date, invoice number, the list of products from the invoice, and so on. This process runs in debug mode, which slows it down and highlights each activity so we can see each step easier. After extracting the data from the invoice, the robot will open SAP and log into the application. The login details can be stored in two very secure ways, either in the Windows Credentials Manager or on our server, UiPath Orchestrator, which has a very secure 256 bits encryption. The UI element identification works with SAP just as it worked with our AnyTeller application. Buttons, form fields, and all UI elements are easily identified. However, there may be some cases where scripting needs to be enabled on the SAP server. If this can't be done, UiPath has other methods to accommodate and solve this issue. Moving on, robots can work with multiple applications simultaneously. In the next example, our robot will work with 7 applications at once: Excel, Word, PDF, email, SAP, terminals, and Salesforce. The Excel file contains the name, email, SAP number, and an individual code for each person. The robot will first read this data, then open the terminal, input each person's code, and get all the data from the terminal. The emails from the CSV will be input into Salesforce to find every employee, and then the expense data from the terminal will be added into the expense row. After this, the robot will create a Word document from a template with a status report for each person. The Word file will then be converted to PDF and sent as an email attachment. Finally, the robot will find the employee's position in SAP and with all of the above data will populate the Excel file used in the beginning. Now, let's start the robot and explain the process in more detail. The robot will start by opening the terminal, Salesforce, and SAP, and by logging into all 3 systems, preparing all the applications it will work with. It will browse the pages of the terminal and find the ID of the first employee. Then identify the same person in Salesforce based on their email address. The expenses are then added in Expense IT, the Word template filled in, converted to PDF, and sent as an email attachment. The robot then finds the position of the person in SAP, then moves on to the second person, looking for the ID in the terminal. After collecting the data, the robot sees that Salesforce does not display an account for Joan, so it creates one. After doing this, it fills the expenses on Joan's account, creates the Word document, converts it to PDF, and sends it as an email attachment. Then the robot moves on to the third person, and so on. Fast forwarding, we can see that all the data is completed in the Excel file for each person, and the emails for each person are sent with a PDF attachment. Next, let's talk about virtual desktop automation. The best and easiest way to automate an application that is running on a remote machine is to install the robot on said machine. But there are situations when this is not an option, and the only way to connect to a remote machine is through a virtual desktop solution, such as Remote Desktop, Citrix, or VNC. Now, as you can see, the same software used in our previous examples is now installed on this virtual machine. Now let's try to automate it. We can see that the UI Explorer does not recognize elements inside this remote environment because the remote machine window is by design treated like an image. So instead of the element recognition we saw earlier, we must now use image recognition to create this automation. We'll create a new sequence and design an automation that operates the software on the remote machine through the virtual desktop. Let's start the Citrix recorder and create a recording based on image recognition. First, the robot must find an image containing the text cache in. We can then instruct the robot to click to the right side of the cache in image in the edit box. Using the type into activity, we will type a value into the edit box, say 123. Next, we'll look for the accept button image and click on it. Finally, we need to extract the transaction ID. To do this, we'll use the scrape relative function, which finds the image containing the transaction text on screen and scrapes the text located to the right of this image. Scraping is done via OCR, which stands for Optical Character Recognition. Now, there are three scraping engines integrated with UiPath. Microsoft Modi and Google Tesseract are included out of the box, and Abby OCR is available as a plugin. For each of these engines, you can select the language, the type of characters expected, like numbers, letters, uppercase only, and so on, but we'll use Google OCR for now. Let's save and exit. As you can see, the recorder has generated a workflow based on image automation with all the steps previously mentioned. The final step in the sequence is the result of the OCR scrape, which should return the transaction number. To check if the scrape data is correct, let's use a message box activity to display the value in the UI container class variable. So the robot is running locally, but it's able to automate the application installed on the remote machine, and as you can see, it can correctly retrieve the transaction number. And that's not all. Even if the remote desktop application window changes the position on the screen, or if the application window inside the remote desktop moves, the automation will still go through. Now, this is possible because the robot is searching for the images and image relatives. The usual pitfalls of image automation, such as unpredictable scaling from the virtual connection, are avoided. Also, if the resolution changes or the application's aspect is altered somewhat, the robot can still identify the correct images by lowering the accuracy of the identification algorithm. The default value is 0.8, with 1 being a perfect one-to-one correspondence. Choosing to go for a lower matching accuracy value, say 0.6, will allow us to find the image even if it has a different resolution. And this may be useful when the quality of the image on the remote environment drops, when there's poor connection, for example. And finally, we might have an interface where the same image appears multiple times. For example, 3 different cache-in images. The robot will be able to identify each image separately and select the correct one. Until now, we've talked about UiPath Studio, which is a tool for developing workflows, and robots, which run the workflows developed in Studio. The final piece, UiPath Orchestrator, is used for managing deployed robots, usually for larger enterprises that use a substantial number of robots. The first thing we need to do is link our robot to the orchestrator. To do this, we go into Robots, Provision Robots, then open the Robot Settings console. To make sure that the robots can talk to Orchestrator, we need to configure our robot with the same robot key and Orchestrator URL. Let's give it an appropriate name, like Mr. Robot. Now that our robot is provisioned, we can see it as being available in the list of robots and ready to be added to an environment, a fancier name for a group of robots. This environment is what we're going to run our automation on. In our case, let's use the existing environment F Society, which already contains another robot, Elliot. Let's publish our existing workflow, Hi World, to Orchestrator. It's a simple workflow which simply shows a message box with this text. To do this, we'll use the Publish button in Studio, then look at the package version 1.0.6235.39618. Back to the Orchestrator. We are now ready to create our process by linking the package we have just deployed. Notice that even if we have multiple versions of the Hi World package, the latest one, 39618, is already available and ready to use. By hitting Enter, we have created the package, which will run as a new job. Let's select the Hi World process and run it on our newly deployed robot, Mr. Robot. The orchestrator will now connect to our local robot and instruct it to perform the automation we've previously uploaded to it, namely to print Hello World on the screen. The orchestrator allows us to also schedule a process. Let's quickly start a schedule to run on the Hi World F Society process within the next minute. Then look at all the other options. As we can see, we can schedule a process to run once every couple of minutes, hours, days. We can run it weekly, monthly, or by using more advanced cron expressions. Under Execution Target, we can specify that the process would run on all robots, or specific ones, or a certain number of robots. Oh, our scheduled process was just triggered. Let's disable it, however, for the rest of this demo. Under Assets, we can define some information that can be shared between multiple robots within Orchestrator. Think of it as a centralized repository where you can safely keep text values, booleans, numbers, or credentials. For this example, let's use a real name text asset and give it the value Elliot. In UiPath Studio, we can access these credentials by using the Server Orchestrator package, using the getAsset activity and specifying the real name asset name. We can retrieve the text saved in UiPath Orchestrator, namely Elliot. UiPath also makes use of queues to distribute the load of a transactional process among multiple robots. They also allow a transaction to be retried a couple of times before being passed onto a human operator to deal with. Queue items can be scheduled to begin before or after a certain date. Under Transactions, you can see detailed information about how queue items were processed. In the Logs tab, information is aggregated about how the robots performed, what tasks they completed or failed. In Audit, an administrator can trace every step that a user has performed in Orchestrator. Speaking of administrators, we can see under the Users tab that UiPath Orchestrator supports role segregation. Here you can see the predefined roles and their permissions, as well as create new roles. Finally, let's look at alerts. UiPath Orchestrator will alert an administrator if something goes wrong, if a new robot connects to Orchestrator, or a connection is interrupted. Here you can see our successful notifications from earlier today. And that was it for today's session. We briefly covered the UiPath Studio and created several workflows involving both the automated recording wizards as well as activities, both in a desktop and a remote environment. We looked at UiPath Orchestrator, the management solution for enterprises, and some of its features. We hope you enjoyed this, and if you have any other questions, feel free to drop us a line at uipath.com.